and welcome to Project 2.2 Persistence of Vision. In this project, I have an alphanumeric dual display connected to two 595 shift registers. The two ICs still do not have enough outputs for both digits. So, what they do is they switch the common cathode so that way each digit can be lit up one after the other. This gives the impression of both digits being lit at the same time, hence the name persistence of vision. This is the square wave oscillator. It is responsible for switching the digits. Over on this white wire here is where the square wave is provided. Then it is placed on both base pins of the transistors. On the NPN side, the first common cathode digit is set to ground as the rising edge of the square wave activates the NPN transistor. While on the PNP side, it stays non-active or low until a low signal is provided over the square wave. Once a low signal is present on the square wave, the PNP transistor sets the second digit to ground. This is how we're able to switch between digits on the alphanumeric display. This is the 74HC595 shift register. The shift register is able to take 3 inputs and convert it into 8 outputs. The first input pin being data. Data is a string of binary values, 1 or 0, in which flood the storage modules of the 595. The first datum would end up on the 8th module, the second input pin being clock. Clock is just a simple square wave which keeps the serial device and 595 in sync. Finally comes latch. Once all data values flood the modules, to keep from the display flickering while these data modules are being loaded in, it waits on latch. It waits until latch is presented with a rising edge, and then it converts all of these data potentials into the latch register. From this latch register, it presents these outputs over the output pins. I failed to mention the fourth input that I'm using, output enable. This is simply to prevent ghosting. I turn the display off while switching digits and then back on before the next digit is displayed. The black bars connecting the output of the ICs to the input of the displays are SIP resistor networks of 470 ohms. They work as documented in this schematic. The serial monitor begins with a prompt. Enter in a 2-letter string and then click send. Even if the user enters in lowercase letters, the serial monitor will return all uppercase, as will the display. Unfortunately, I was not able to get the lookup table into my EEPROM, so I'm writing it into RAM. In the setup function, it begins by waiting on the serial. Then it declares all active pins to output. Down in the loop function, we can see the serial print the prompt. These are long switch statements that have every letter of the alphabet, only in uppercase. These switch statements figure out the corresponding segments that must be turned on for each letter. At the bottom, here's where the square wave is being flipped from low to high. And finally, here is where the data is being written into the IC.